In this tutorial, we're going to look at how layer 2 switching actually works. Here's our simple topology in Packet Tracer. 2 layer 2 switches, each with a host connected. Our goal is for host A to reach host B across the switch network. So we start with a ping and it works. But behind that simple success is a lot happening at layer 2. Every switch maintains a MAC address table and it learns MAC addresses automatically. A switch learns a MAC address when a frame arrives on a port. It records the source MAC and the port it came in on. Before the ping can even happen, host A sends an ARP request. ARP uses a broadcast MAC address, so the switch floods it out all ports in that VLAN, and you can see that broadcast flood here. As the broadcast travels, the switch learns host A's MAC address. When host B replies, the switches learn host B's MAC address as well. Now both switches have complete MAC tables and traffic can flow directly without flooding. So these switches are connected using a trunk link. A trunk carries multiple VLANs using 802.1q tagging, which keeps VLANs isolated while sharing the same physical link. And here we can send VLAN 10 or VLAN 20 traffic and see how it is tagged and forwarded. So to keep the network stable, we use spanning tree protocol. STP prevents loops by electing a root bridge and assigning each port a role, such as a root port, designated port, or alternative port. So ports transition through states like blocking, listening, learning, and forwarding. And you can see those transitions here in the STP panel. So as the network converges, switches exchange BPDUs, block redundant links, and eventually settle in a loop-free topology. Finally, let's have a look at a full frame builder. Here we can break down every part of a frame: the source MAC address, destination MAC, VLAN tag, ether type, and payload. So this is the information a switch uses to make forwarding decisions. And now when we return to Packet Tracer, our ping flows cleanly. We have MAC learning, VLAN tagging, and STP all working together to deliver stable layer 2 connectivity. That's layer 2 switching in action.